This week we will start a new chapter. This chapter is about probability. The first section we're gonna learn some basic concepts. In this section we will try to learn how to interpret probability values. And we should also learn a new concept called odds, and we should also learn the relationship between odds and probability. First, let's check some basic definitions. The first definition is called event. So let's check it. An event is any collection of results. So any collection of results, we call it an event. The second one is a simple event. So first, it is an event, and this event cannot be further broken down. Then we call this event a simple event. Okay. The next one will be sample space. Sample space consists of possible simple events. So it's just a set of all simple events. Let's check an example to help you understand these definitions better. So here we will use letter B to denote a baby boy and the letter G to denote a baby girl. Okay, so let's see the procedure first. Procedure 1, single birth. If it's just a single birth, example of event can be a girl, right? It's possible to be a girl. And a girl is a simple event because it's already the simplest form. It cannot be further broken down, right? Let's check the sample space. Sample space is the set of all possible simple events. So in this sample space, we should have B, G. B stands for one boy. G stands for one girl. So that's all the possible outcomes for this procedure. Single birth. So we list all the possible outcomes, and these two outcomes should be simple events. One boy or one girl, they are simple events. So that's why BG is our sample space. This one is easy, right? Let's check if this time the procedure is 3 births. So let's check the example of events. It can be 2 boys and 1 girl for these 3 births, right? Of course, it's possible. 3 boys and 1 girl. Add up 3 births. But we will say 2 boys and 1 girl, this event is not a simple event. It's not a simple event. Why it's not? Because this event can be further broken down. 2 boys and 1 girl, it's possible to be boy, boy, girl. The first 2 are boys, the last one is girl. Of course, it can be boy, girl, boy. And also can be girl, boy, boy. So for this 2 boys and 1 girl event, it can be further broken down into 3 simple events. Something like BBG, BGB, GBB. Right? So all the sample space for this procedure, let's check. It can be 3 boys. So if it's 3 boys, that's BBB. It's already the simple event. Then we list 2 boy, 1 girl. It can be BBG, BGB, BGB, and GBB. GBB is here, GBB. And we also list one boy and two girls. It will be BGG, GBG, and GGB. This event is two girls and one boy. And the last one, GGG, means all of three births are girls. So the possible outcomes are 8 simple events. So the set of these 8 events is called the sample size. So these are the solutions. You can read it by yourself. Let's check the notations for probabilities. Okay, we use capital letter P to denote a probability. Okay, we always use capital letter P to denote the probability. Then we use capital letter A, B, or C denote a specific events. So this P, A, we can say it's just the probability of event A. We use this P, A in the parentheses. We will say this means the probability of event A. So make sure you use the capital letter P and the capital letter A, B, C, something like that. Let's check this graph. The possible value for probability is from 0 to 1. And if the probability value is equal to 0, then we will say this event is impossible to happen. If the probability value is equal to 0, then we will say it's impossible to happen. But if the probability value of an event is equal to 1, then we will say this event must happen or is certain to happen. Then if the value is close to 1, it's very close to 1, then we will say this event is very likely to happen. But if the probability of event is very close to 0, it's very small, it's just like 0.001, then we will say this event is unlikely to happen. So that's just tell you the likelihood of the event. So let's go back to check the property. From the graph, we already know the value between 0 and 1. So we will never get a negative probability or any number greater than 1, something like 2. This is not a probability value, right? The possible probability value between 0 and 1. We will talk about 3 common approaches to find the probability. First, we call the relative frequency, approximation. So most of the time, we will pick this way. In statistics, most of the time, we just use the first way. So let's check what is relative frequency. So PA means the probability of event A, right? So let's check the numerator. It's number of times A occurred divided by the number of times the procedure repeated. Okay, that's the definition or the formula. Then let's check the second approach to find the probability. We call it a classical approach. Maybe you are familiar with this approach, but this approach has the condition requires equally likely outcomes. Then we can use this formula. So in this formula, the numerator shows us the number of ways A occurs and divided by the number of different simple events. So we can say that's kind of like the size of our sample space. So we use letter S divided by N to represent this method, classical approach. Later, we will talk about the examples. The last method we call it subjective probability. So it's just estimated by using knowledge. It's just an estimate. So it kind of like guessing by yourself based on your experience. It's just guessing. Okay, so we will focus on the first one and we will also talk about the second method. But most of the time we will not use the third method. So about the round-off rule, we probably will use a decimal. But if it's a simple fraction, something like this one, it's also fine. Or we will just use a decimal because decimal easy to understand for some student. Okay. And we will round off final answer to 3 significant digits. We can use 3 significant digits. But in my class, I would say both fraction and the decimal will be okay for your answer. So here we have a new rule, law of large numbers. What is this law? Means one procedure. If this procedure is repeated again and again, then the relative frequency probability tends to approach the actual probability. So that's the rule. That's the foundation why we could use the first method, relative frequency method. Because if this procedure is repeated again and again, then relative frequency probability will be very close to the actual probability. Let's check the example. In this example, we will just use the relative frequency method to get the probability. We try to find the probability of dying when making a skydiving jump. Okay. And we have some numbers. We have a report, and in this report we know about 3 million jumps and 21 of them resulted in death. Then we should use the relative frequency method to do the probability. So if we are interested in the probability of death, so death is our event A, right? So according to the formula, the numerator will be the number of times A occurred. So from the background, we know 21 of them resulted in death. So 21 is our numerator. And we check the denominator. Denominator will be number of times the procedure repeated. So here, this jump repeated 3 million times. So the denominator will be the total jumps we have. So it's 3 million. And this will be our final answer. That's the probability of death. Then we can check if we could use the second method, the classical method. Then we get this conclusion. Cannot be used for this example. Because remember, if we want to use the classical method, the event should be equally likely. The event should equally likely. Then we check two outcomes, dying and surviving. They are definitely not equally likely. Right? They are not equally likely. If they are equally likely, so 0.5, one half will die, one half will survive, then I think no one will do that jump, right? So they are not equally likely event. So definitely we cannot use the classical method. Of course, if we do not have any report, any background information, we can use the third method. We just guess the probability of dying. But if we already have the numbers, we just use the first method. Let's check another example. So this example is about taxing and driving. So let's check the question. If a high school driver is randomly selected, find the probability that he or she texted while driving during the previous 30 days. So which method should we use? The relative frequency, classical, or subjective? So let's check the first method, relative frequency. So this time we want to find the probability of the student text while driving. But when we go back to check, we have this number, 3785 texted while driving. And we also know 4720 did not. We want to know the probability, right? Probability texted while driving. So texted while driving is our event A. So how can we get to the probability? We pick the relative frequency. So the numerator will be the times of event A happens, right? So we know it's about texted while driving. So we have this 3785. But what's your denominator? We want to know how many drivers in the sample. So that will be a total number, including texted while driving or not texted while driving. So we go back to check. First, we should get the total number of drivers in the sample, because that's our denominator. So we know this total number of who texted and who did not text is our denominator. So we will get 0.445, remember 3 significant digits, as our final result. So this is our conclusion, our interpretation. This is the probability.